In this video, I'll look at transposing to the standard normal distribution. Now, of course, all normal distributions can be transposed back to the standard one. That's why we only have one table of values. To do that, we're going to have a Y formula, and that formula requires that we know the mean and standard deviation of what we're working with. Diagrams are still going to look the same. And probability statements will look similar. They're just going to have x's and the actual numbers that we're working with instead of the z's and the small numbers between 0 and sort of 4-ish. Here's the formula. Z equals x minus mu over sigma. Mu, the mean, sigma, the standard deviation. X is the value we're going to be transposing back to a z-score. So we'll go through this first example. We're going to do 2 this time just so we can get a mix of numbers. Year 10 height, mean of 167, standard deviation of 8 centimeters. So recall here we've got mean of 167 and standard deviation of 8. What's the probability that we have a height between 167 and 180 centimeters? We need to transpose both of those values. Now you see when I go and transpose this first Z1 value, we'll call it Z1 for the 167, that's going to go to 0. Transposing the mean of any distribution is going to always bring it back to 0 because that's the mean of the standard normal distribution. We also need to transpose the 180, so we'll get a Z2 here, we'll call it Z2. Transpose it, it's going to be 180 minus 167 over 8, which gives us 1.625. Exactly 1.625. If it was more, we would still round to 3 decimal places because we can only look up 3 decimal places in the normal distribution table. So what we're saying here is that the probability x, which is the height, is between 167 and 180, is the same as a z-score between 0 and 1.625. What about a height this time between 160 and 167 centimeters? Well, the 160 is less than the mean, so this time we're going to get a z-score that's going to be a negative, and we know how to handle those. So we get 160 minus 167 over 8 for negative 0.875. And of course we know the mean 167 is going to be mapped to 0. So we've got probability that height is between 160 and 167 is the same as having a z-score between negative 0.875 and 0. What about height bigger than 190 centimeters? Here just one number to transpose. 190 minus 167 over 8 gives us 2.875. So now we're saying height bigger than 190 is same as having a z-score bigger than 2.875. How about some fuel consumption numbers for a rental car fleet? Normal distribution here of mean with 10 liters per 100 Ks and standard deviation of 1.8 liters per 100 Ks. So now we've got a mean of 10 and a standard deviation of 1.8. What's the chance of having fuel consumption between 6 and 12 liters per 100 Ks? Again, we're going to do 2 Z transformations here. Z1, negative 2.222. Remember, we're rounding that to 3 because that's how many numbers, 3 decimal places, because that's how many numbers we can look up in the normal distribution table. Z2, 12 minus 10 over 1.8, 1.111. So z-score, that's equivalent to having fuel consumption between 6 and 12 is the z-score between negative 2.222 and 1.111. What about having fuel consumption less than 7 liters per 100 Ks? Well, that's just 7 minus 10 over 1.8 gives us negative 1.667. So the probability of having fuel consumption under 7 liters per 100 Ks is the same as z-score less than negative 1.667. And that's it for this video.